All right, guys, this is Mr. Ainsworth. Good morning. We are going to get into section 2 in your homework here, and we're going to take a look at how to show, or explain why each one of these numbers is rational. Okay, so it makes sense to start off with like, what in the world is a rational form? What does a rational number mean? All right, so let's do that. Okay, so we got to explain why it's rational. So let's talk about rational form. So up at the top, let's write rational form here. Now, rational form looks like this, where it's a over b. Okay, that's a b right there. A over b, where a and b are integers and b is not a zero. Okay, because you can't divide by zero. So a and b, are integers. You can write it out in words right here, or you can do it symbolically if you like. You can say a comma b is an element of, use the element of symbol. Okay, z for Zahlen, for integers. And b is not equal to 0 because you cannot divide by 0. So basically, rational form, in other words, because a and b are integers, is an integer, divided by another integer. And it's also important to know what an integer is. So let's talk about the set of integers too. Because if you don't know what that is, obviously you can't visualize it. So let's talk about integers just for a moment. So let's write down integer. Again, the integers are the whole numbers, 0, 1, 2, 3, 4, so on, and their opposites. So we're going to start off with their opposites, like -3, -2, -1, 0. They're starting the whole numbers here, 1, 2, 3, and so on. So those are the integers. And when you have an integer divided by another integer, you have what's called a rational number. And any number that can be expressed as a ratio of two integers is called rational. So here we go. Let's get right into it. So they call it 0.25. It's called 25 hundredths. That's how you say it correctly. So 25 hundredths. There's not even a need to reduce that if you don't want to, because 25 is an integer, 100 is an integer, and that's rational form. You have an integer divided by an integer. 3.5. Well, 2 times 3 is 6, plus 1 is 7, so this is 7 halves. And again, you have an integer divided by another integer, so that's rational. -7 can be expressed as -7 divided by 1. And again, it's an integer divided by an integer. So let's talk about C, for example, because a lot of people think that the whole numbers, or their opposites, like -7 right here, is not rational because it's not a fraction. Well, remember, you can write any number, if you can write any number as a fraction, like I just did, divided by 1, it's rational. Believe it or not, -7 is a rational number. Integers are a subset of the rationals. So, continuing here. 0, well, you can express 0 any way you like. So how about 0 divided by 2? 0 divided by 7, 0 divided by, let's say, -3. They're all 0, right? So 0 is a rational number because it can be written in many different ways. As long as the numerator is 0, all right, you have a 0 fraction or a 0 result. 5 divided by 3 is obviously a fraction. So you get 5/3, that's rational. 5.9%. It's 5.9 divided by 100. All right, so what does that equal to? Well, I'll tell you what. Let's write that as a fraction. Let's multiply both numerator and denominator by 10 and rewrite it as integers, because 5.9 is not an integer. So you have to multiply it by 10/10. So I'm going to do that here. You can do that. You can multiply it by any form of 1. So what do you get? You get, obviously, 59, all right, divided by 1,000. All right, 59 thousandths. And guess what? 59 and 1,000 are both integers, so therefore it's rational. All right, -2 to the third power, or -2 to the -3 power, is 1 divided by -2 to the third power. You apply the negative exponent rule. -2, all right, times -2 times -2 is nothing more than -8. So this is equal to -1/8. And that's rational, because 1 and -8 are integers. It's an integer divided by an integer. Okay. Next one, when you square root a fraction, you just square root its parts. That's all you do. And you get 3/2. Okay, and that's rational. This one here, I'm going to do the opposite of what I did in H. I can square root the parts of a fraction, well, I can rewrite it as 1 root. So this right here is just the negative of the square root of 2/18. That's just the square root of 1/9, all right, which is negative 1/3. Okay, so that's rational too. Okay, because negative 1 and 3 are both integers. So negative 1, an integer, divided by another integer is rational. Okay, we're rocking. Okay, so the next one here, you got the cube root. Okay, the cube root. So this right here is represented as, well, it's called the cube root. So you would be thinking, like, what number cubed raised to the third power gives you negative 27? So what number x raised to the third power gives you negative 27? That's how you think about this. All right, and if you take negative 3, all right, negative 3 to the third power, you get negative 27. Because negative 3 times negative 3 times negative 3 is negative 27. So the result here, even though it doesn't look like a fraction, it is, okay? So it's rational. All right, it's negative 3, and you write that as a fraction if you like, or a ratio of two integers, negative 3 over 1. Where both negative 3 and 1 are integers, so that's rational form. And now we get into the fun ones here. We get into the logs. Now remember, logs are just the result of an exponential. Okay, and in this case, the base, common log, let's call it common log. Okay, it's base 10. When you don't see the base, it's base 10. So it's called a common log. Okay, sorry about my pen here. So then when you want to be thinking, when you think logs, okay, you got to start off with a base. Okay, this is called a base. It's base 10. Sorry, excuse my pen here. There you go. Let's see if I can get it going. All right, and you got to ask yourself, 10 to what power gives you 10? 10, you start every log, you start with a base, and you ask yourself, 10 to what power gives you this number here? And then this is this other 10 here inside the log here is called the argument. So 10 to what power gives you 10? Let me write that out. 10 to, what power gives you 10? And the answer's got to be 1, right? So 10 to the first power gives you 10. All right, so the result here is nothing more than 1. You can even try that on a calculator if you like. If you want to try take the log of 10, you'll get 1. This one here, you got to be thinking, okay, inside here first. You first had to figure out the log base 2 of 16 is. So you think, let's go over here off to the side. You got to be thinking in a certain fashion, okay? So you got to take the base 2 to what power gives you 16. 2 to what power gives you 16. That's how you think about a log. You always start off with the base. Okay, so obviously 2 to the first is 2, 2 to the squared is 4, 2 to the third is 8, and 2 to the fourth is 16. We know 2 raised to the fourth is 16. So this right here, the log itself is equal to 4. Okay, so what I just did is I evaluated the log here. All right, the log of 2, log base 2 of 16 is 4, and then you take the square root of 4, and it's 2. So the result is 2, and 2 can be written as a fraction or a rational number, as an integer divided by an integer. So this actually, even though it doesn't look like a rational number, or something that can be written as a ratio of two integers, it is. Okay, 2 is 2 over 1. Now here on this one, it's base 4. Okay, so you got to be thinking 4 to what power gives you 2. Now here, if x cannot be some positive, or excuse me, it can't be a whole number like 1, 2, or 3, because 4 to the first is 4, 4 squared is 16, 4 cubed is 64, so this x value is obviously less than 1. And we know that 4 to the 1/2 power is the same thing as the square root of 4. Okay, the 1/2 power, as you learned in Algebra 2, represents the square root, okay, which is equal to 2. All right, so this right here is actually equal to 1/2, all right, which is rational. Okay, see, the logs are the results of an exponential. You got to keep that in mind. Now, on the next two trig problems here, you might want to access what's called the unit circle. All right, now 2/3 pi. 2/3 pi is an angle. All right, and let me just talk about 2/3 pi here. So 2/3 pi. Pi is 180 degrees. So when I look at this, I think 2 times 180 divided by 3. And 180 divided by 3 is 60 times 2, or 120 degrees. That's how when I see pi, I think 180. 180 divided by 3 is 60 times 2 is 120. So this is the same as this is equivalent to the cosine of 120 degrees. The question is, what is that? So you go to unit circle here. Okay, and you go to the unit circle and you find 120 degrees, or 2/3 pi, which is right up here in this. It's a quadrant 2 angle. So this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Okay, and on the unit circle here, radius 1, you have to understand that the x-coordinate of all these points on these angles, the x-coordinate is the cosine of the angle, theta, and the y-coordinate is the sine of the angle in all these points on the unit circle with radius 1. All right, so again, it's always x comma y, right? Yeah, that should be known. So if it's x comma y, and then it's cosine x comma sine x, or cosine theta comma sine theta, where theta is your angle here. Whether the angle is a quadrant 1 angle or quadrant 2. Quadrant 1 is over here between 0 and 90. Quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270, or 3/2 pi. And then, of course, quadrant 4 is between 270, which is 3/2 pi, and 360 degrees over here. Okay, so we want to evaluate, what was it? Let's go back to the problem here. So the cosine of either 2/3 pi or the cosine of 120 degrees. All right, so let's get that value. So we look at the x-coordinates. So we find 120 degrees, okay, or 2/3 pi, and we find that is negative 1/2, because cosine's negative in quadrant 2. All the x values in quadrant 2 are negative. The y values are positive. So let's get that value, so negative 1/2. So this is nothing more than negative 1/2, which is an integer divided by an integer, and that's why it's rational. Okay? There are other ways to do this, okay, using the 30, 60, 90 triangles. Okay, that's how I do it. I don't have to use a unit circle, but that was the quickest way I can show you guys. Pi force. Okay, pi force is the same thing as 180 divided by 4, and that's 45 degrees. So what we need to do is find the sine of pi force, which is quadrant 1. 45 degrees is right here. It's pi force. And the sine of it, okay, this is the sine of pi force, is the y-coordinate. The sine of pi force is equal to rad 2 over 2. Okay, you can also get that from your triangles too. So again, 45 degrees is pi force. Okay, and the sine of that, SOHCAHTOA. Okay, SOHCAHTOA from basic geometry here. Sine is opposite divided by hypotenuse. Okay, and you take the opposite side. Actually, let's take this one here. So, which is 1 divided by hypotenuse, which is the longest side of the triangle, and you get root 2. So it's 1 over root 2. And if you rationalize that, you get root 2 over 2. So let's take that value. Okay, so we have to evaluate this one. This is going to be the square of pi force, sine of pi force, excuse me. That's the equivalent way to think about it. That's easier to handle too, by the way. You evaluate the sine of pi force first. Okay, and then you square it. So let's take it down here. So that equals sine of pi force. That's rad 2 over 2, or 1 over root 2. Then you got to square it. 1 squared is 1, obviously. And then if you square the root 2, you get 2. All right, and so the result is 1/2, which is an integer divided by an integer, right? Which is irrational. Okay, there you go. And that is how you show that each one is rational. You got to show that you have basically a ratio of 2 integers where the denominator is non-zero. All right. Now, since it's a video, of course, you can always rewind it if you need to listen to it again. So use your video effectively. Now, we're going to get right into 2b1 as well, because once you have rational numbers, then the first thing before we construct them is to just locate them and be accurate on the number line. Okay, so when I say be as accurate as possible, okay, I want you guys to divide the segment up into equal parts. Okay, so divide segment, the unit segment, okay, segment in equal parts to figure out where the fraction lies. Okay, so when you figure out where 1/2 is, okay, obviously you divide it into 2 equal parts. So we're going to do that. So I'm going to divide that into 2 equal parts right here. Okay, now notice this is just an approximation. This is not with a compass or a straight edge or a ruler or anything like that. So you estimate the position of 1/2. So notice that the unit length right here, this is 1 unit. 1 unit on the number line right here is divided into 2 equal parts, and you can figure out where 1/2 is. So on the figure out to 1/3 here, you have to divide the segment into 3 equal parts. So divide, all right, the unit segment or the unit into, all right, 3 equal parts. Equal parts, that's the key. All right, so let's do that. So we got 1 here, we got 1, 2, see, they're not equal. So let's try it again. So you have to, somehow, there you go. That's a little bit better. So now we have 3 equal parts, okay, and 1/3 is right here. Okay, 1/2 is here, 1/3 is here, and then 2/3. This part right here, that'd be 2/3 right here, and this would be 3/3. Okay, but I wanted to represent, where is 1/3? Well, it's 1 part out of 3. Okay, so on the next one here, you have to divide the unit segment into 4 equal parts, right? I mean, 1 part out of 4. So I'm going to divide it in half, all right? Then I'm going to take the halves and divide it in half again. They should be in equal parts, and you get 1/4, okay? And that's the idea. You want to divide it equally to figure out where the fraction lies. So for 1/5, you're going to do your best, and you're going to divide it into fifths there. Let's see if I can do this decently here. That's not the greatest. Let's try it again. 1, 2, 3, 4. So 1, 2, 3, 4. That's not bad. So 1/5 is 1 part out of 5. So 1/5 would be right here. There's 1/5. 2/5, 3/5, 4/5, 5/5. Okay, divide into 5 equal parts. Divide into 5 equal parts. That's key. All right, 3/5. Okay, similar idea, right? So I just did 1/5, so let's do 3/5. So let's do 1/5, 2/5, 3/5, 4/5, 5/5. Let's locate 3/5. So go 1/5, 2/5, 3/5 right about here, and you label 3/5. So to do it accurately, it's all about dividing into equal parts. Now in the next one here, 5/2 is equivalent to 2.5, which is between 2 and 3. So I'm going to go an equal distance across and find 2, and equal distance across to find 3. And then I'm going to divide it up into equal parts, 2 equal parts to locate 2.5, or I can put 5/2 up here. Okay, so you have to show where 2 and 3 are to determine where 2.5 is. Okay, next one, 11/3. Well, that's 3 and 2/3. All right, obviously 11 divided by 3 divides 3 times, remainder 2, so it's 3 and 2/3. So I have to go over 3 units to the right, because it's 4 units to the right, because it's between, obviously, 3 and 4. So I estimate it's 2, 3, and roughly 4. And then I have to divide that unit length into thirds, like I did previously. So this is 3 1/3 here. So this one right here would be 3. All right, and 2/3. Be accurate. Okay. And then the next one here, and -3/2. Well, what do you do? Well, let me see. -3/2 is the same as -1 and 1/2. So we got to go over here on the other side of that 0, 1 unit away. And then let's go over here to -2, 2 units away, equal distant apart. And then you have to divide that unit up into halves. So go ahead and do that. You get -3/2 here. or you could write it as negative 1.5. So it's right here on the number line. All right, so just show the location. Okay, so negative 2.25 is obviously between negative 2 and negative 3. So let's go over here to the left. So negative 1, negative 2, negative 3 is over here. So negative 2.25, you have to divide that up into equal parts. So let's do that. So equal parts, divide in half, divide the halves in half. And there we go right here. And we get negative 2.25. Divide it up into fourths. Okay, and that's all there is to it. Now, the reason why we're doing that, that's just a very simple basic activity, going back to grade school, believe it or not. But it gives you an idea of where these fractions are located, these rational numbers as we call them. And then what we need to do next, okay, is how to find the exact location on the number line using a compass and a straight edge. Okay, so there's activity 2B1. And previously here we talked about how to show that numbers are rational. So explain why each one's a rational number. All right, so I will see you in my next lesson. This is Ainsworth, or Sensei, as you're calling me now, because I've got this crazy bandana on after my surgery. And I will see you on my next lesson. All right, take care. Bye-bye.